Welcome to This Explainer. Today, we're diving into an absolutely monumental shift in how we create technology. For decades, building software meant you had to learn incredibly complex syntax, fight with configuration files, and essentially force yourself to speak the computer's language. Well, that barrier, it's completely falling away. We're transitioning from writing lines of rigid code to building full-stack applications using nothing but natural language. We're going to move from the perceived magic of AI straight into the underlying mechanics and finally to how you can master these new tools.
Okay, let's dive right in by anchoring ourselves in this powerful new reality. We've officially entered what Google Cloud's Ajath Prabhakar calls the era of vibe coding. So what does that actually mean? It means the technical friction is just gone. You simply describe your vision, your vibe, your layout, your logic, and the AI deploys a fully functioning web application to production in literally minutes. It's a complete democratization of the software lifecycle, and it is a real game changer.
Here's our roadmap for today. We'll start with the vibe coding revolution. Look at how AI actually reads through tokenization, explore AI variance and temperature, check out the multi-agent solution, and bring it all together on the infinite canvas. Starting off with Section 1, the vibe coding revolution. Let's see how the very definition of an application is evolving right now. So the crucial takeaway here is that you, the human, can now step into the role of a system architect or a creative director. Think about the massive cognitive load of traditional programming for a second, remembering strict syntax rules, debugging tiny typos, resolving endless configuration conflicts before you even see a single button on a screen. With vibe coding, all of that heavy lifting is handed over to the AI. You get to focus entirely on the layout, the flow, the user experience, the overall vibes of the app. It's like you're directing the orchestra rather than trying to play every single instrument yourself. Moving to Section 2, how AI reads tokenization. Because to truly master these tools, we really need to look under the hood. You see, AI doesn't speak English or Spanish or Python the way we do. It speaks math through something called next token prediction. Historically, researchers faced a massive problem when teaching AI to read. On one extreme, you have word-level tokenization. Now, it makes intuitive sense to us humans to treat every word as a number, right? But it's incredibly brittle. You end up with this massive vocabulary explosion because run, running, and ran all need totally different numbers, and it completely breaks down if there's a simple typo. But on the other extreme, character-level tokenization solves the vocabulary problem by just using single letters. The catch? Breaking things down to single letters means the AI loses the actual semantic meaning of the words. It's kind of like trying to understand a novel by only looking at the alphabet. And this brings us to Byte Pair Encoding, or BPE, which is the absolute industry standard today. BPE is the bridge that turns our human vibes and natural language into manageable numerical IDs by elegantly splitting unfamiliar words into recognizable subunits. But here's why this matters for you. How does this encode your design system? Well, when you describe a visual design pattern, say a rounded blue navigation bar with a subtle shadow, BPE tokenizes that exact intent. It breaks those complex visual instructions into subword tokens that AI agents, like Maya 4 and Raina, can actually process mathematically. This encoding is the exact mechanism that ensures your visual design intents are translated accurately into production-grade code, maintaining perfect design consistency across your entire full-stack application. All right, Section 3, AI variance and temperature. Let's see how the AI actually decides which token to predict next based on developer settings. So the AI calculates a probability distribution of what the next token should be, and you control its choice using a setting called temperature. If you want the AI to write a creative poem, you'd want to balance temperature around 0.8, which allows it to pick slightly less common tokens to be engaging and diverse. But what if you're using AI to write secure authentication code for your backend? No way, you absolutely cannot afford creativity there. You need the strict absolute consistency of temperature 0, which is known as greedy decoding, where the AI always picks the single highest probability token. But here's a wild fact that catches so many new developers off guard. Setting your temperature to 0 does not actually guarantee 100% perfect exact matches every single time. Why? Because of the physical hardware running the AI. Due to GPU floating point non-associativity, which basically means parallel math operations don't always sum up in the exact same mathematical order, along with server-side concurrent batching, you get tiny, tiny variations. So even at temperature 0, you shouldn't expect a perfect match. Actually, scratch that. It's more like expect 95 to 99% similarity. This is exactly why having a robust platform to manage this output is just so critical. Next up, Section 4, the multi-agent solution. Let's zoom back out to the macro level and see how modern platforms harness these token predicting engines to actually build your app.
In the early days of AI coding, you talk to one AI bot and inevitably get stuck in this frustrating sequential debugging loop because a single AI just loses track of the context. Modern platforms like Ajath solve this brilliantly by utilizing a virtual dev team. They use up to 10 parallel agents, literally naming them like human teammates: Maya 4, Raina, Jacob, and Matt. These agents take your tokenized design system and work concurrently. While Maya 4 is coding your front-end UI, Jacob is simultaneously designing your database schemas, and Raina is setting up secure authentication. Because they are all processing the exact same encoded design intents in parallel, they maintain absolute consistency across the entire full-stack architecture. It's incredibly efficient.
And finally, Section 5, the infinite canvas. Let's explore how you, acting as the human architect, oversee and master this incredible multi-agent process. This step-by-step workflow beautifully demystifies the entire app-building lifecycle today. It all comes together on the infinite canvas. You start by prompting your idea in natural language. Immediately, those parallel agents start coding everything concurrently. But step 3 is where the magic really happens for you as the designer. You can visually tweak the layout directly on the infinite canvas. And when you make a visual change, that change is instantly encoded back into tokens via BPE, processed by the agents, and the production-grade code updates in real time. It completely eliminates the gap between design and development. Plus, because it utilizes zero-setup full-stack infrastructure, your tweaks immediately update a live, shareable URL. To wrap up this explainer, I want to leave you with this provocative thought. We've looked at the math, the tokenization, the temperature, and the agents. AI is now more than capable of handling the complex mechanics of coding and infrastructure. The deep technical barriers that might have held you back yesterday, they are officially gone today. So the only real question remaining is, how will you use vibe coding to bring your own ideas to life? What are you going to build when the only limit is your imagination? Thank you so much for joining me to explore this incredible revolution in software creation. Now go out there and start building.